Halo, selamat siang dan salam sejahtera bagi kita semua. Di sini kami ingin memaparkan hasil diskusi kami tentang mechanical fastening. Sebelum kami memaparkan hasil diskusi kami, ada baiknya kami memperkenalkan diri. Kami dari kelompok 5 proses manufaktur, kelas ME 4E, Politeknik Negeri Medan. Perkenalkan, nama saya Romel H. Panjaitan. Saya sebagai moderator dan penyaji.
Perkenalkan, nama saya Reza Rizal Purwa dari kelompok 5.
Perkenalkan, nama saya Renja Christopher Tonga dari kelompok 5.
Perkenalkan, nama saya Romario Leman Siotang, anggota dari kelompok 5.
Perkenalkan, nama saya Jepang Panel Pardede dari kelompok 5.
Mechanical fastening. Mechanical fastening adalah proses penyambungan material menggunakan fastener atau pengikat. Jenis fastener atau pengikat ini bisa berupa nail atau paku, bolt atau baut, screw atau skrup, pivot atau keling, dan lain-lain. Umumnya digunakan pada bangunan konstruksi baja dan jembatan. Adhesive bonding digunakan untuk mengikat dua permukaan yang biasanya menghasilkan ikatan halus. Teknik ini menggunakan glue exposed atau macam plastik agen yang dibentuk akibat penguapan pelarut atau dengan melepaskan ikatan dengan panas, tekanan, dan waktu. Welding adalah proses penyambungan material dengan menggunakan energi panas sehingga menjadi satu dengan tekanan.
Kelebihan dan kekurangan mechanical fastening dan welding. Kelebihan mechanical fastening adalah dapat mengontrol bentuk dalam materi yang diinginkan karena proses permesinan material dilakukan dalam keadaan solid. Welding, adanya distribusi aliran tegangan yang seragam sehingga kekuatan tariknya baik. Kekurangan mechanical fastening adalah bentuk yang tidak baik, akan menyebabkan timbulnya crack atau cacat sehingga kekuatan terhadap batik menurun serta kurang ekonomis apabila desainnya kurang tepat karena akan menyebabkan tumpang tindih terhadap desain komponen. Welding, material atau logam yang akan dilas mengalami perubahan mikrostruktur karena pengaruh panas yang diberikan atau logam mengalami pasca cair.
Bagian-bagian dari mechanical fastening. 1. 3D fasteners. 3D fasteners merupakan suatu alat atau komponen pada perakitan produk yang digunakan untuk mengkaitkan komponen satu dengan lainnya. Baut dan skrup biasanya yang digunakan untuk menyambungkannya. 3D fasteners memiliki standar dan spesifikasi seperti dimensi ulir, toleransi dimensi, peak, kekuatan dan kualitas material yang digunakan untuk menahan getaran mur dan penguncinya, ditingkatkan tahanan geseknya dalam menahan torsi. Berikut adalah contoh-contoh produk 3D fasteners.
Dua, permanent fastening method. Permanent fastening method merupakan pengencang permanen yang memberikan solusi yang kurang lebih tidak bergerak. Setelah mereka berada di tempat, mereka tidak dapat dihapus, bahkan oleh orang yang awalnya menginstalnya, tanpa menyebabkan kerusakan pada aplikasi. Skrup permanen juga disebut sebagai skrup satu arah, karena sebagian besar fitur kepala yang dirancang untuk mengubah arah saja, sehingga mereka dapat diskrup ke tempatnya, tetapi tidak dapat dibuka. Beberapa aplikasi seperti patung atau bangku taman dirancang untuk tetap di tempat untuk kesenangan semua orang. sehingga pengencang atau perbaikan permanen biasanya digunakan di sini untuk mencegah perusakan atau penghapusan, juga digunakan untuk mengamankan plat nomor kendaraan karena mereka membuatnya hampir tidak mungkin untuk melepas plat tanpa merusaknya. Berikut foto dan contoh produk permanen fastening method. Terima kasih.
And you work with designing,
building or repairing things, one of the things that you should know about are the different types of fasteners. When it comes to putting things together, there are always lots of different ways that you can do it. Some materials can be chemically bonded, welded, soldered, or brazed together. Other situations call for adhesives like tape, glue, or epoxy. But today I want to talk about mechanical fasteners and explain the difference between some of the common types that you're likely to run into. Mechanical fasteners are things like nails, screws, nuts, and bolts that we use to secure things to other things. If you've ever walked into a hardware store in search of a fastener, it would be easy to get overwhelmed by the variety of options available. How do you know which one you need? Fasteners come in different sizes and shapes, with different points, heads, drive types, materials, surface finishes, and surface coatings. There are thousands upon thousands of different varieties of mechanical fasteners, and for a given application there might only be a couple of options that will work properly. The friendly staff at the hardware store can probably help you find what you need, but you don't want to be the ill-informed chump who goes in there not knowing the difference between nails and screws. So let's get down to the basics of mechanical fasteners.
Nails are normally straight fasteners without threads. They have pointy tips because they're designed to be pounded into soft materials like wood, usually with a hammer. Softer woods like pine work well with nails. The nail can easily force its way into the soft material, and the wood presses back on the nail to hold it tightly in place. Harder woods like oak or maple don't take nails so well, and are likely to split apart when the nails are driven into them. That's why nails are the preferred way to attach boards in home construction because framing lumber is normally made from soft woods that are easy to nail. Like other fasteners, there are countless different types of nails used for different purposes. Framing nails like this one have large heads that are easy to pound with a hammer, and also easy to pry out if needed. These are usually hidden inside the walls of the building, so they aren't designed to look good. Finish nails are used for applications like trim and molding, where big ugly nail heads would be visible and unpleasant. Finish nails are thinner, so they'll be less likely to split the wood, and they have tiny little heads that are designed to be hard to see once they're driven in, or recessed beneath the surface to be covered with wood filler or putty. Roofing nails, on the other hand, are designed with big, wide heads. They're used to hold down asphalt shingles, and the wide head helps ensure that the nail will hold the shingle down without breaking through it. Roofing nails also have a galvanized coating that protects them from rust, since they need to work outside where they could be exposed to the elements. Nails for different applications will have very different design features. Some have a coating of glue that melts from the friction of being driven into the wood and helps hold the nail in place. Other nails are designed to be driven into different materials like masonry or drywall. Besides just being pounded in with a hammer, nails might also be driven in with a pneumatic or electric nail gun. They can even be driven into especially tough materials using the explosive force of gunpowder. Screws are a very different type of mechanical fastener than nails. Instead of being pounded straight into the material like a nail, screws have to be turned into the material. For a fastener to be a screw, that usually means that it has a sharp point and a long, coarse thread used to bite into softer materials like wood, sheet metal, or even masonry. Unlike nails, screws can usually be tightened, loosened, and taken in or out pretty easily using a screwdriver or electric drill. Like nails, screws come in lots of different sizes with different design features for different applications. Some have a weatherproof coating for outdoor applications like decking. Some have decorative surface finishes to match hinges, brackets, or other hardware. One of the biggest differences between types of screws is the type of drive used to turn the screw. Slotted screws like this one require a flathead screwdriver to turn them. Phillips head screws like this one have become more popular because the screwdriver is less likely to slip inside the screw head while driving the screw in or out. Other screws might use a Torx drive like this one to enhance the grip between the driver and fastener even further. Large lag screws might use a hex drive that can be driven with a wrench, or some specialized fasteners like furniture screws, set screws, and other mechanical fasteners might use an inverted hex drive like this, which uses an Allen wrench to turn. Besides the type of drive, another important difference between types of screws is the shape of the head. Some screws have cone-shaped heads like this, which make them easier to recess below the surface of a piece of wood. In harder materials, a cone-shaped recess called a countersink might be needed to help recess the screw head. Other types of screws might have very differently shaped heads, which can be important if you have a very specific application in mind, or if you're trying to match the style of an existing fastener. Heads with a flat bottom are generally designed to sit on the surface of the material, but might also be recessed below the surface using a counterbore, or a larger hole that the screw head sits in. Screws can wedge their own way into softer materials pretty easily, but when using screws in harder materials like hardwoods, it's a good idea to pre-drill a pilot hole in the wood to make space for the screw. The pilot hole is a little smaller than the threads on the screw, so the threads will still bite into the material and pull the pieces together. The first piece normally gets a bigger hole called a clearance hole that the screw can pass right through. This ensures that when the screw tightens, the threads will bite into the second piece and pull the screw head tight against the first piece, forcing out any gap between the two pieces. A drill bit like this one is designed to drill the pilot hole, clearance hole, and countersink all in one shot.
So the next time you need a screw, you should have some idea what kind of screw you're looking for. Bolts and screws share some similarities. Some even go by misleading names that can be a little bit confusing, like a lag bolt or a set screw. But in general, the biggest difference between a bolt and a screw is that a bolt has much finer threads than a screw, which are designed to thread together with a matching threaded fastener instead of actually threading into the building material itself. Like screws, bolts come in all different shapes and sizes with different types of heads, drives, thread patterns, and surface finishes.
Unlike screws, bolts normally don't have a pointed tip because they're designed to drop through a pre-drilled clearance hole and have no need to drive their way into the material. The most important thing that distinguishes one bolt from another is probably its thread pattern. The thread pattern of a bolt or nut is very specific and standardized. The things that make one thread pattern different from another are its diameter, number of threads per inch, pitch or distance from one thread to the next, and allowance or the tightness or looseness of the fit between threads. There's a wide range of thread patterns used with standard measurements and with metric. Trying to connect a nut and bolt of two different thread patterns won't work. So it's important to use the correct thread whenever using threaded fasteners. An advantage of bolts over screws and nails is that they can be tightened with a wrench to be nearly as tight as you want. They aren't so likely to snap off or strip out the threads inside the hole. Another piece of bolt is a washer, which is a flat ring, usually metal, with a hole that fits pretty closely around the bolt. The washer helps spread out the surface area of the bolt head or nut to apply pressure over a larger area. This gives the bolt head a bigger surface to grip and also prevents the head from forcing its way into the material. To prevent nuts and bolts from loosening over time due to use or vibrations, a lock washer is sometimes used to put a little outward pressure on the nut and bolt to prevent it from spinning off on its own. Like the other fasteners, washers come in a variety of styles and materials for different applications, and so do nuts. Acorn nuts might be used in decorative situations or to prevent snags on the loose end of a bolt. Wing nuts are designed to be loosened and tightened by hand without the need for a wrench. Lock nuts have a nylon ring inside them that bites tightly onto the threads of the bolt to prevent it from coming loose, and the list goes on. In other situations, the bolt might not thread into a nut at all. It might be designed to thread into a tapped hole, which is a hole drilled into a piece of material that then has threads cut into it to receive a bolt. Just like the connection between a nut and a bolt, the thread pattern of the bolt must match the thread pattern of the tapped hole for this to work. The possible combinations of nuts, bolts, and washers is almost endless. But as I said before, there's probably only a few combinations that will work properly for a given application. So the more you know about the possibilities, the more likely you are to make the right choice. The last type of mechanical fastener I want to talk about today is the rivet. A rivet is basically a metal pin that is put through a hole, then widened on each side so it can't slide back out again. With a tight enough fit, rivets can secure things extremely well. Rivets are used to hold together lots of different kinds of materials, including sheet metal, plastic, leather, fabric, and plenty of others. Rivets are even used to hold together some of our biggest, strongest structures, like steel bridges. In the days of old, iron workers would have to heat up rivets in a furnace until they were red hot, then quickly throw the red-hot rivet to another worker who would catch it, slide it into a hole between a gusset and beam, and then pound the ends flat before the rivet could cool off. Nowadays, installing rivets is a little easier. Pop rivets like this one are cheap and easy for people to use at home. They're installed using a rivet gun like this one, which can be hand-powered or pneumatic. First, a hole is drilled through the pieces that the rivet will connect. Then the rivet slides through the hole. The pin end goes into the rivet gun, and when you squeeze the handle, the pin is pulled back toward you. On the way, it deforms the thin metal sleeve that it sits in, squeezing the two pieces of material tightly together. When it can't tighten anymore, the pin breaks off, leaving the expanded rivet tightly in place with a smooth, clean-looking face on the outside. Several rivets together make an even stronger connection. Just like other mechanical fasteners, rivets come in lots of sizes and varieties. The length of the rivet dictates the thickness of material that it can join. Different diameters have different amounts of holding strength and require different sized holes to be drilled. Steel rivets are tougher and harder to install and remove than aluminum ones. On cars, special plastic rivets are often used to secure plastic body panels to metal ones or to the steel frame of the car. These rivets come in an endless list of sizes and styles, many of which are specific to certain types of vehicles. So it pays to know exactly what you're looking for if you ever need to go to the store looking for rivets.
Some people will never know the difference between the types of mechanical fasteners or what they're used for.
These are the people who will likely have to hire someone else to do simple jobs and repairs for them around the house.
Even things as simple as hanging a picture frame or assembling a piece of furniture become a whole lot more difficult if you don't understand the basics of tools and fasteners.
Sekian dari hasil presentasi kami. Jika teman-teman ingin bertanya lebih detailnya, teman-teman bisa mengajukan pertanyaan ke WA Group. Sekian yang bisa kami sampaikan. Atas perhatian teman-teman dan dosen pembimbing, kami ucapkan terima kasih.